All right, today we're going to start looking at lesson 4.2, which is on rate of change and slope. We're going to look at the fact that these two are very, very similar, if not the same concept, and how we're going to calculate slopes given a line or just given information about a line. So, first of all, the idea of slopes of lines. The slope of a line is the rate of change of the y coordinates, which is the rise, for the corresponding change in the x coordinate, which is the run for the points that are on the line. Okay. Now, M is the letter, cursive M is the letter we use to represent slope. I don't know why for sure, but that's what we use. And we say slope equals rise over run. And it's the change in Y values over the change in X values. Now you see this subscript 2 and a subscript 1, like it's Y2 minus Y1 over X2 minus X1. Those represent the ordered pairs from which those points came from, and I'll explain more of that as we go. But you need to remember that slope is rise over run, and it's the difference in the y's over the difference of the x's. A lot of people will mistake this and put x over y. It's got to be y over x. Okay. Now, the slopes of lines, there's four different ways this can happen. We can have a line that has a positive slope, which means this line is going to rise from left to right. You're going uphill. Okay. Positive slope rises from left to right. It can have a negative slope. When a negative slope is a line that falls from left to right. So as you look at the line and you move along that line from left to right, you're going downhill. You can have a zero slope. A zero slope is a horizontal line. So a flat line has no slope. Okay. Now those are our lines that are written as y equals a number. Those are horizontal lines. And then you can have a right here's the showing you that the slope of a line like this, if I calculate it using my formula up here, I'll get 0 over a number, 0 over 2, 0 over 10, 0 over -8. Doesn't matter. If the numerator is 0, I have 0 of those. And that means I have 0. That's a horizontal line. Okay. An undefined slope is the slope of a vertical line. It has no slope. It only has rise. It has no run. It just goes up. Okay. And when I calculate those, I get a number over 0. Okay. And whenever you have 0 in the denominator, it's undefined. If it's undefined, it is a vertical line. Okay. So those are the four ways our slopes can unfold here. The first set of questions you get are pretty straightforward. They give you four different lines and ask you, is it positive? Is it negative? 0 or undefined? And I mean the slope, is it? So looking at the first one, this is a vertical line. Okay. It's all rise. There's no run. When you get a vertical line, you need to note that that slope is undefined. Our second one, as I move left to right, I'm going downhill. Okay. Whenever you go down from left to right, you get a negative slope. The third one, I'm going up as I move left to right across the line. I'm moving up. When I move up, it's positive slope. And in line 4, it's a flat line. Okay, there is no rise. It's all run here. It's flat. Those lines have a 0 slope. There's no rise or run. It's just a 0 slope. Okay, another group of those, just to run through them again. The first one, line 1, that's a horizontal line. It's flat. It has no slope. Line 2, as you move left to right, you are increasing. You're going up. That is a positive slope. In line 3, as you move left to right, we're going down. When you move down from left to right, it's a negative slope. And 4 is a vertical line. It's all rise. There's no run. This is no slope. Okay. It's an undefined slope. Okay. So that's your first set of questions. The second idea is to find the actual slope given a graph and given two ordered pairs on a graph. So if I'm given a situation like this, a lot of times there's two different ways you can do the problem. Sometimes the most direct way is the easiest way. So they're telling me, or we know slope is rise over run, right? So what is the rise and the run to get from this point to that point? Well, you're going to go up 3 units, 1, 2, 3, and you're always moving vertical and horizontal. Okay. So you're going up 3 and you're going over 5. So to move from this point to that point, I have a rise of 3 and a run of 5. And that's it. You're done. Now, the other way you could do this, calculate slope using the slope formula. So look at this point as an ordered pair, -1, -2. That's this point. The other point is located at 4, 1, and then take the ordered pairs and put them into the formula. So I'm going to go y minus y2 minus y1, 1 minus negative 2 over the x's, 4 minus negative 1, and 1 plus, or excuse me, 1 minus negative 2 is 1 plus 2, right? Negative becomes positive, that becomes positive. You get 3 plus a positive, this becomes 5. It's the same answer. A little easier the first way we did it. Okay. Now we knew that was going to be a positive slope, right? Because we were on the rise from left to right. We know this slope's going to be negative. We're going down from left to right. Okay. So again, what I would do if I'm you is I'm going to travel from one point to the next. So rise, I'm going to go up 6 units. 1, 2, 3, 4, 5, 6. Now moving up along the y-axis is positive, correct? To get to this point, I got to move to the left along the x-axis. Whenever you go to the left on the x-axis, you're moving in a negative direction. So it's a rise of 6 and a run of -5 because I went to the left. Okay. Maybe jumping over here real quick. Remember, I went up, which is positive, to the right is positive. That's why those two are positive. Now I'm going up, which is positive, but to the left, which is negative. So I got a rise of 6 and run a -5. I'd write my answer as -6/5. Okay. The other way to do it is to do use the slope formula. So this point is located at -3, 2. This point is located at 2, -4. Take these points and plug them in our formula. So I'm going to go y values 2 minus -4 over x values -3 minus 2. And minus a negative is plus. So 2 plus 4 is 6. This becomes plus -2. -3 plus -2 is -5. And it's the same answer. The way we did it the first way is a little easier. Okay. So that's how we find the slope from a graph. Now, what if they just give us an ordered pair, set of ordered pairs, and say find the slope of the line? Well, we're going to use slope formula for sure here, right? Now, let's talk a little bit more about this x1 or y2 minus y1, x2 minus x1. All this is referring to is the xy value from the ordered pair. So let's say I called this first one my first ordered pair. -4, -3 is my first ordered pair. So that's the x from the first ordered pair, x1. That's the y from the first ordered pair, that's y1. Then this one's my second ordered pair. So 8 is the x2, -9 is the y2. It's just the y from the second order pair. So if I follow my labels here, I'm going to get -9 minus -3, y2 minus y1, y2 minus y1 over x2 minus x1. That's 8 minus -4. So this is going to become -9 plus 3 over 8 plus 4, -6 over 12, which is -1/2. Now, just so you get a clear picture of this, I can switch these two. Let's say I decide to make the -4, -3 my second ordered pair and the 8, -9 my first ordered pair. Okay, follow the rules. We're going to get the same answer. Okay, so now what I'm going to do is y2 minus y1 is going to be -3 minus -9 over -4 minus 8. Okay, -3 minus -9 becomes -3 plus 9. -4 minus 8 is -4 plus -8. That's going to give me +6 over -12, which is -1/2. So my point is, it doesn't matter which one you want to call x1, x2, and y1, y2. Okay, you just have to make sure that you are consistent. If this y is the first number I use, then the x has got to be the first number I use in my subtractions. Okay, so it doesn't matter which one's which. That's my point here. Okay, so take another one like this. Here's the ordered pair. Okay, here's my slope formula. I'm going to call this one the y2 or the x2 y2, this one the x1 y1, and we're going to just use the values as I see them. So it's going to be 6 minus 2, the difference in the y's, 9 minus -7. Okay, 6 minus 2 is 4, 9 minus -7 is 9 plus 7, so that's 4 over 16, and that's 1/4. That's it. Okay, you don't have to do it two ways. I just wanted to show you up here that the which one you decide to make the first and second order pair makes no difference in the answer. You're going to get the same answer. Okay, the next concept is to look at rate of change or slope in an application question. So this says Linda makes house calls. For each She is paid a base amount, and then she makes an additional money for each hour she works. The graph below shows her pay in dollars versus the number of hours she's worked. And we're going to use the graph to answer the questions. All right, so you can see here's the number of hours worked, 0, 1, 2, 3, 4, onward. Here is pay, it's in dollars, so 0, 10, 20, 30. We're going by groups of 10 here, groups of 1 here. Okay, so we got to understand the scale of it because that matters when we look for our slope. First question is, what is her base pay for making a house call? Well, her base pay is where the graph starts. So what this means is she's getting $40 just to go to the house call. And then she makes money based on how long she's been there. So $40 is her base pay. How much does her pay increase for each hour worked? Okay, well, let's take a look. If I go up $10, I go over 1 hour. So a rise of 10, a run of 1. For every hour she works, she makes $10. Okay, so this is slope. We worked up 10 over 1, up 10 over 1, up 10 over 1. This is a consistent slope. All right. So what does this mean? How is her pay? Well, it's a rise of 10 and a run of 1. $10 per 1 hour, or we could just write $10 an hour. So she makes $10 for every hour she's there. What's the slope of the line? Same thing, guys. Rate of change, they call it rate of change because rate means you're using units, different units. Okay, slope is just, what's the slope? Well, the slope is a rise of 10 and a run of 1. The slope is 10. The rate of change is $10 an hour. I'm putting labels on it. So slope and rate of change are the same number. Rate of change is more, hey, let's put some numbers on it to explain what it means. Slope is just, hey, we're going up 10 over 10. That's what the line's doing. Or up 10 over 1. That's what the line's doing. Okay. And then last of all, I put another one in here. So buckets being filled with water. The graph below shows the height in millimeters versus the time the water's been running in seconds. So looking at the graph here, here's my time, and it's by 1 second or 1 second. And here's my height. It's by 5 millimeters. They're going by fives here. Okay. And you can see that we're starting at 0. So the bucket's empty when we start doing it. Okay. First question, how much does the height of the water increase for each second? So it's a rise of 5 millimeters for every 1 second of time. So up 5 over 1, up 5 over 1. We can keep going, up 5 over 1. It's a consistent rate of change. So the idea is, for this is describing it now unit wise. So it's 5 millimeters of rise for every 1 second of run. Or we could just write 5 millimeters per second, right? What's the slope of the line? The slope is now with no labels. It's a rise of 5, run of 1, which is, we ever get a number over 1, we can just write the number. So it's 5. The slope of the line is 5. All right. So there's a look at slope, how we calculate slopes different ways, and a look at rate of change, how rate of change and slope are so closely related, and what the little differences are between them, which is really just labels and explaining. But that's the type of problem we're going to work on tonight. So please, get it done on Alex. I don't think there's all that many questions to work on, and I will let you get at it.